Welcome back to the next video. So here we're looking at displaying numerical data part 2. So we're going to concentrate on stem plots or stem and leaf plots. So it's just another way of arranging the data so that we can get some useful information about it. So what I've done here, just concentrate on this bit here on the left at the moment. So this is spawning trout are caught, weighed and then released by a fisheries inspector. The weights of 20 fish in kilograms are as follows. So we've given a table of data which ranges between 0.8 and 3.2, and that data has been arranged here in this stem plot. So stem and leaf, essentially I think this is like the stem and the data grows out this way as the leaves. I think that's the reason they call it that. So the idea with this is, like we had dot plots to represent each piece of data, and we built up a little picture to see how the data was distributed. With stem plots, we're actually using the data itself. The important thing is to understand what all these numbers mean and how to read it. So the first thing I want to point out is a key. Every time we do one of these, we must put a key because it tells us how to read the information in the stem plot. So there's always a line that separates one row of numbers. So these are essentially our groupings, and this is the rest of the data. So what's happened is we're taking, if our piece of data is 0.8, we're taking the first part of the number and writing it down here, and the rest of the data, the 0.8 part, as just an 8. So this key would say equal 0, line 8, it actually equals 0.8. So that would be this in combination with that. The 9 is a 0.9. All these bits of data are all the measurements that start with 1 point something, 1.1, 1.2, 1.5. So it's important that you put a key so that you tell the person reading this information how to read the information. An alternate key, if this was different data, this could represent 11, 12, 15, and in that case, this is how it's represented in the stem plot, and this is what the actual data is. So it's important that when you decide what your key is going to be, you use that to represent the data. The other idea is each number we're going to try and keep in nice straight columns, so that essentially each piece of data, if you look at it this way, it's like a horizontal histogram almost. So it sort of shows the distribution of the data. So most of the data is in the 1 point something category, grouping, I should say. Yeah, so and I suppose another thing to stress is all the data is arranged in order. So from smallest, 0.8, 0.9, smallest to largest as we go through. In order to create these, you'll be given a box of data, and in the same way that we need to be really careful not to miss a bit of data or misrepresent a bit of data, the best way to make these I think, is to, as you go through the data, write the numbers out in non-numerical order, and then either erase each line at a time and reorder them, or rewrite it again. But I'll show you that when we get to an example. Okay, so this stem plot on the right is essentially exactly the same data as this, except what we've done is broken each of these groupings into two halves essentially. So where we have a little star, that actually represents all the numbers from 0.5 upwards, 1 up to but not including 0.5, 1.0.5 onwards. So it's like we did in grouping data before, but the reason we put a star is if we wrote 1.5 here, it would make interpreting the key a little ambiguous. So we just put a star for every second grouping to tell the person looking at the stem and leaf plot that we've broken all the numbers that start with 1 point something into two halves. And sometimes when the reason for doing this is if you get too much data all grouped in just a couple of the groups, it might be worth separating them out to see how the data sits. I suppose some of the advantages, I mean, we can divide them into different subcategories, but it can get a bit messy, so we're just going to stick with this convention for now. So the advantages of this is, when we were talking about frequency tables, the frequency would just tell us there's 2 things in this group, and there's 8 things in this group, and 6 things in this group. We've got our data arranged in the form of a horizontal histogram, but we haven't actually lost any data. We still know that 3.2 was one of the original collected data scores. When we group things and we just count how many things are in each group, we sort of lose what all the scores are, but we get an idea of how many scores are in each grouping. Yeah, so when I look at these, I tend to turn my head to the right, try and think of them more as vertical, but it gives you an idea of the spread of the data in a vertical. So when we were talking about histograms and the spread sort of in these directions, oops, it's sort of turning that sideways and looking at it that way. Okay, this is our first example that I'm going to go through and create the stem plot. So the information says a taxi driver collected the following fares over one evening. Data has been rounded to the nearest dollar. Represent the data in the form of a stem plot. So first of all, I'm just going to look at the data and look at the kinds of numbers that we have. So I notice that there's an 8 in here, and how big do they get? 54, 53. Okay, so the numbers range from single digit numbers up to numbers in their 50s. So that's going to inform me on how I'm going to group all this data. So I'm going to say, if we group it single digits, start with a 0, the 10s, 20s, the 30s, the 40s, and the 50s. My line, so I'm going to put a key before I even start. So let's, and it doesn't matter what you represent the key with. It doesn't even have to be one of the bits of data. It's just the indication of how to read the key. So let's just say 1 line 2, that will equal 12. Okay, so what I'm going to do, first I'm going to do this out of numerical order, and then I'm just going to rewrite everything I do here in another representation of this, except I'll reorder everything. Okay, so the first thing is 18, so cross that off, and I'm just going to put an 8 next in the 1 row. 16, another 8, 15, 18, 5, 12, 36, 9, oh, 6, 2, 3, 15, 4, 7, 8, 9, 2, 3, 2, 8, 4, 38. Please notice how I'm trying to keep these numbers in nice neat columns so that the distribution is still able to be read. 1, 5, lastly 18. Okay, so I've taken all the data, I've just thrown it into whatever group it belongs in, but it's not actually, you know, ordered from smallest to largest. So what I'm going to do, so I'm going to rewrite all this over here. Same groupings, 0, 1, 2. But as I go through each column, I'm just going to reorder them. Well, this one's already done, from smallest to largest. 6, 7, 8. In the 1 group, we've got 2, 4, 5, 6 in there, 4 8s, and another. So notice I haven't crossed everything off, but it's just to keep track of what I've written down. Over here we've got a 2, a 4, 2 5s, and a 9, a 2, 6, 7, 8. 4, we've got a 2 and a 3 already in the right order, and then here we've got a 3 and a 4. So the shape, let's just write that here again. 1, 2, 12. So the shape is essentially the same, but we've just shuffled everything around so that now it goes from smallest to largest. So our smallest score was 6, our biggest was 54. The 10 up to 19 group had the most bits of data, the most scores, and it sort of tailed out that way. So that's essentially, so then this, I'd put a cross through that because this is actually what the question's asking for. Okay, so let's do one more example. Okay, so here's the next example. So this is I think it's the same data that we looked at earlier, the tree girth measurements. Represent the forest as tree girth measurements in the form as a stem plot using class intervals of 5 centimeters. So here's where we're going to use that star notation, because rather than representing the start number of each group to represent the whole group, we're just going to split that into 2. So looking at these, we've got 104. How low do they go? 86, 88, 83, 81. Right, so I don't think we have anything lower than 80. So I'm going to say that our groups are going to go from 80 to 85, 85 to 90, 95 to 100, and then 100 to 105. So how that then translates into stem plot is we have our, so we're going to take the first digit as the stem and the rest of the number as the leaf. When we get to 10, we'll put a 10, so you'll see 8, 8 star. So this is all the 80 numbers, all the 85 and above, the 90 numbers, 95 numbers, and the 100 numbers. There's our line, and let's just put the key here. You can see that. And let's use this slash line 3 equals 103. Okay, so let's we don't need that now. So I'm going to do the same thing. I'm going to go through each separate bit of data and put it on the stem plot, and then I will redo it again over here. Let's just get this ready. And over here, hopefully we'll get it in numerical order. So, first one, 102. Starts with 102. 81 in that group. 99. It's in the 90s, but it's bigger than 95, so it's in that group. 3 is in that one. 100. 95. So this is 9 up to, but not including 95. So 95 goes in this group. In that group. 3. 9, 2, 8 in that group. 104. 96. Whoops. 8. Get it right. Yeah, it's easy to make mistakes. Then we've got a 96. 2. 96. 93. 93 in that group. 4. 1. 6. 5 is in that group. 96. Okay, so now I'm just going to rewrite exactly, so we're going to come up with the same shape, except we're just going to reorder everything so that we go from smallest to largest. So this first row is already done. We just have to move that 6 to the front. 8. We've got here 0, 2, 2, 3, 3, 4. 4, fit this in. What have we got here? 2 5s, 3 6s, and 8, 2 9s. So I'm having to squeeze that in there. Here we've got a 0, 1, 2, 3, 2, 3, and then 2 4s. There we go. So, and of course that key belongs to this one over here. So we can sort of see how the data is spread out, broken into these smaller group sizes, and that's essentially it. So it's just another way to organize numerical data. Okay, so that's where we're going to leave that one.